In this video, we're going to learn about digital signatures and digital certificates and how they are used to transmit encrypted messages. So what is a digital signature? Well, if you think about a sender's private key, the thing that they're not meant to share with other people, if you take that and you encrypt it using a hashed digest of the message that you're going to send over an encrypted pathway, if you use that hash digest to encrypt the private key, that's an example of a digital signature. It proves that the sender is who they say they are. But why is a digital signature actually needed? Especially when you're dealing with digital certificates. Well, if you think about a certificate that's being sent from the client to the server, if we use a digital signature and kind of wrap it around the outside of the digital certificate, when it gets to the server, when they're validating the certificate, they can make sure that that certificate is genuine and it's not been altered in any way. So we know what a digital signature is, but what is a digital certificate? Well, essentially it's just an electronic identity card that enables trustworthy communication of information over the internet. It uses something called PKI, or Public Key Infrastructure, which is in itself a set of rules, policies and procedures that you need to manage the use of certificates. And as part of the PKI, you've got a number of certificate authorities, and each certificate authority is used to create and verify an individual digital certificate. Now, you know from a previous slide that the digital certificate contains the digital signature, okay, that's encrypted hashed digest of the message. But it also holds other things, such as the detail of the certificate authority that issued it. It's also got the expiry date of the digital certificate. It'll have information about the sender, so their username, the computer they use, maybe the network device or the IP address. It's also got the sender's public key, that's really important. And it's also got details of the hashing algorithm that was used to generate the digital signature. And that's also very useful. If you're ever asked to name some items, here are 6 perfectly acceptable ones. The most important ones are the ones that you should really go for first, is the sender's public key, details about the sender, obviously, where the certificate comes from, and unless it's already said it, the digital signature. The expiry date and the hashing algorithm used, they're good to know, but you probably get full marks on a question by knowing just the 4 marked with a star. Now remember that a digital certificate comes not from the computer that's sending the message, but from a certificate authority. So you need to know how a digital certificate is actually issued by the certificate authority. There's 4 steps involved. Number 1, the user's private and public key is generated. Number 2, the user submits an application to the certificate authority, and they include the user's public key, obviously, and other details that we talked about on the last slide. The data is encrypted using the certificate authority's public key. Okay, so you think of it as a 2-way communication between the user, which is the client, and the certificate authority, which is the sender. When you have any sort of encrypted communication, you swap public keys. So the certificate authority public key will be known to the user. So that's how they can use it to encrypt the application. Step 3, the certificate authority creates a document, okay, that's going to become the certificate, and that includes the user's data that they've shared. And once they've made the document, they digitally sign it using the certificate authority's private key. And again, the certificate authority's private key is only known to the certificate authority, so it can't be, it can't be spoofed. And step 4, the digital certificate, now that it's been signed by the CA, is sent back to the user and can be used in communication with other servers. So the user can then communicate with, for example, Gmail, and the digital certificate can be used by the Google servers to ensure that the messages coming from the user are actually authentic. Yeah, okay, but how can you ensure that a message is authentic? There's really just the 3 steps to this. It's really simple. The receiver, so the machine receiving the message, looks at the sender's digital certificate, and then it uses the sender's public key with the hashed message that was received to produce a message digest. And from that message digest, you compare the generated hash with the digital signature that's on the digital certificate. If it matches, then you can say that the message is authentic.